Why does increasing your speed actually decrease your acceleration? Well, let's take a look with the help of Sky. Sky loves the feeling of only the force of gravity upon them, except it's not the only force. Every time Sky skydives, they feel two forces, the force of gravity and the force of drag. Now, for a second, let's assume there's no force of drag. Sky would keep falling and falling with a constant acceleration, which would constantly increase their speed. Sky would keep speeding up forever, unless they hit the ground, of course. That's where the force of drag is so important. The drag force, also known as air friction, works in the opposite direction of the gravitational force. Now, the drag force is directly proportional to the velocity. So, as Sky's force increases, they accelerate and their velocity increases too. But if their velocity increases, then the force of drag also increases, showing how we got from this small force of drag at the very beginning to a much larger one. So when does Sky start slowing down? Or, that is, stop speeding up? Well, since the force of gravity and the drag force are working in opposite directions, Sky will stop having an acceleration when the drag force and gravitational force are balanced. Acceleration is due to a net force, so when the net force is 0, Sky will be moving at a constant velocity. We can see exactly when this will be by utilizing Newton's second law. Newton's second law states that the net force is equal to the mass times the acceleration. We established what the force of gravity is and what the drag force is. By adding these equations together, we get that ma is equal to mg minus the air friction constant, which is k times velocity. We do some rearranging, we get acceleration is equal to gravity minus the air friction constant times velocity over the mass. Now, we want there to be no acceleration, which means it moves at a constant velocity and it stops speeding up. We set this to 0, and then do some rearranging, we get mg is equal to kv. And that leads us to this equation. The terminal velocity is equal to the mass times gravity over the air friction constant. Terminal velocity, when the drag force and gravitational force are balanced out and there's no acceleration, so it's a constant velocity. So you don't keep speeding up forever. You keep moving at a constant velocity.